Sure, sir.
ওই যে সেশন ওই যে আব্দুল ইলিয়াস আক্তার স্যার যে খুলনা ইউনিভার্সিটি, হ্যাঁ
জি স্যার।
ওনার একটা প্রেজেন্টেশন আছে, আমি কো-অথর তার সাথে 14 ওই 2টা 10-এ, হ্যাঁ
জি স্যার।
তো ওই পেপারটা ওনার ওখানে কারেন্ট নাই এবং ওই ওখানে তো একটা গন্ডগোল চলতেছে, হ্যাঁ
জি।
ওই যে এক টিচার মারা গেছে, কারেন্ট নাই, আজকে সারাদিন কারেন্ট থাকবে না এবং ওখানে নেটে খুব প্রবলেম হচ্ছে। উনি এইমাত্র ফোন করলো তোমার সাথে কথা বলার পর যে আমারে দিতে বললো, তো আমার এইটা একটু লাস্টে দেওয়া যায় না 15টা 30-এ?
আচ্ছা, রিশাফল করে দাও স্যার।
রিশাফল করে লাস্ট ম্যান দিয়ে দিও আমাকে, আমার এখানে একটা প্রোগ্রাম আছে এই জন্য আমি দিয়ে দেবো তার পক্ষে, কিন্তু আমার 15টা 30-এ দেবো, হ্যাঁ
ওকে স্যার, ঠিক আছে।
মানে 3:30।
স্যার সেক্ষেত্রে কিন্তু আপনার টাইম শুরু হবে মানে 15টা 10 থেকে 15টা 30।
হ্যাঁ 15টা 10 থেকে, হ্যাঁ 3টে থেকে আমি থাকবো।
জি
3টে থেকে, ঠিক আছে, এটা একটু রিশাফল করো কাইন্ডলি। হ্যাঁ ওকে, থ্যাংক ইউ।
ওকে। Okay, hello again to ICMCS 2021. I hope you can see me and also see my screen. So this technical session 5, which is climate change and future climate projections. We're glad to have the Honorable Session Chair, Professor Dr. Hiroyuki Ishikawa, Professor Emeritus from Kyoto University, Japan, and also the Honorable Session Co-Chair, Dr. Muhammad Abul Kalam Malik sir from Bangladesh Meteorological Department to conduct the session. So I am just now handing the session to both Ishikawa sir and also Malik sir to conduct. Thank you, sir.
Thank you.
Okay, hello everybody. I'm Hirohiko Ishikawa, the former professor of DPRI Kyoto University. So I have already retired, but it is my honor to be invited as the chairman of these sessions. The session will be starting 30 minutes later. Prior to the sessions, I asked the speakers, presenter in this session, to keep the time. So it is, I know it is a little difficult to keep time in the web seminars. So because we are always apart in different places. So please be reminded to keep the time presentation. The presentation time is 20 minutes for each presentators. So I hope everyone to finish their presentation in 15 minutes, and then we hope the fruitful discussion in the remaining 5 minutes. So you know, this topic is one of the highlighted topics in these years. In recent years, you may have many questions and many discussions. Okay.
Thank you, sir. I will maintain the time. Before 5 minutes, I will alarm the presenter, and the presenter will then drop the presentation, and probably 3 minutes will be permit for question and answers. It will be okay?
Okay, but I think just alert is okay. So so we have another maybe 15-minute discussion time with right. So maybe a small extension of the presentation. It's okay for me, for everyone.
Okay. Thank you, sir.
So now it's 30 minutes before, 30 seconds before I'm going to start. So you know, the session title is Climate Change and Future Climate Projections. You know, this topic is gather many attention from the people, and one of the highlighted research topic in recent years. So the first, the keynote speech is given by Professor Takemi from DPRI, Kyoto University. The Japanese researchers now are not only keen to the global warming itself, but they are now keen to the disaster, hazard and disaster caused by the global warming issues. And also they are going to do the research of adaptation to those disasters. The presentation, keynote presentation from Professor Takemi is related to the hazard caused by the global warming extreme weather conditions. So please, Professor Takemi, please.
Thank you. Can you hear me?
Yes.
Okay.
Yes.
Thank you,
Clear and
Ishikawa-sensei,
loud.
Professor Ishikawa. So let me start my presentation. Actually, I'm not going to talk too much about climate change, but I'm going to talk about high-resolution modeling of strong wind hazard in urban districts in order to use this information for climate change adaptation strategy. My name is Tetsuya Takemi from Disaster Prevention Research Institute, Kyoto University. So in my talk, I will focus on airflows within urban districts. As you know, in densely built urban areas, there are high-rise buildings, low-rise buildings, and densely distributed, which will affect significantly the airflows within urban canopy. This is a conceptual figure showing the airflow patterns in urban districts. Over flat surface, airflow follows log scale distribution in the vertical under neutral condition. But in urban district, there are too much influences from high-rise buildings and open spaces, parks, and trees within urban streets. So turbines may affect the strong wind hazard in urban districts. The conceptual figure showing flow patterns in urban area is demonstrated in this figure. This figure indicates how flow patterns are different depending on the distribution or density of roughness elements, which mimics the urban buildings. If the density of building is very low, flow is like isolated roughness flow and not too much interact with each other, but the density of building becomes higher. There are interaction between airflows caused by individual buildings. And if the density becomes too high, airflow within urban canopy becomes small. So flow pattern depends on roughness density. This figure shows how the airflow are different, significantly affected by the variability of building height. This is a largely simulation analysis of airflows, turbine airflows over roughness obstacles. In the upper panel shows the airflow patterns over roughness obstacles with equal height. And what I'm showing by the color shading is the vertical momentum transport. In the lower panel shows the airflow patterns and momentum transfer over roughness obstacles with variable height. So comparing these two figures, you can find that the intensity of momentum transport is higher in the lower panel, in which building height varies with the building height varies significantly. So the height variability influences the turbine structure and turbine's behavior in urban districts. This kind of information critically important in order to think about climate change adaptation. This figure indicates how hazard, impact assessment, and adaptation mitigation interact with each other. In order to think about climate change adaptation strategy, we need accurate impact assessment, and impact assessment requires hazard information. So this hazard, impact assessment, and adaptation mitigation strategy interact with each other. In order to provide accurate information for climate change adaptation, we need downscaling, and downscaled information is interpreted to be used for policy making. Today, I'm focusing on strong winds hazard and strong wind disaster caused by a significant typhoon over Japan. This specific typhoon is called Typhoon Jebi, which occurred in September 2018, which hit over Osaka, Kyoto area. And these photos shows the damages of houses and trees and houses and buildings. In Osaka City, the maximum wind gust, observed wind gust was 47.4 meters per second, which is the third record in the observed history. And also Kyoto, we observed about 40 meter per second wind gust, which is the second record in the observed history. So we would like to quantitatively represent this kind of wind hazard. In order to obtain the typhoon wind speed, we use the regional meteorological model, the weather research and forecasting model, WRF model, to represent typhoon winds. So we use nested domains to cover a specific region, downscaled from 4.5 kilometer to 0.9 kilometer, 900 meters per second. And we specifically focus on the Osaka City area. We use very high resolution building data set at 2 meter grid spacing, and we cover the densely built district within Osaka City. And white area shows the computational domain for building resolving large area simulation model at 2 meter grid spacing. Okay. So first, we perform downscaled experiments using the WRF model. The left panel shows the distribution of maximum surface wind, wind speed at 10 meter height, and at each grid point. So color shading shows the wind speed, magnitude of wind vector. And you can see that during the passage of typhoon, some region experience very high winds. For example, if you focus on Osaka City, which indicated by white area, about 25 meters per second wind speed was simulated. However, actually in the Osaka City, the maximum wind gust is around 47 or 48 meters per second. So in order to quantitatively represent the maximum wind gust, we need more high-resolution modeling. For this, we use the building resolving large area simulation model to capture the wind speed variation. So we focus on Osaka City area. And during the typhoon passage, the dominant wind was southerly. So we prescribed a southerly wind inflow for the large area simulation domain. And the upper figure shows the computational domain of the large area simulation model. From the left, southerly wind were prescribed as a lateral boundary of the large area simulation domain. And the lower right panel shows the horizontal distribution of the maximum wind speed at each grid point by using the large area simulation model. This is scale normalized wind speed, and U infinity is the wind speed at the boundary layer top. The height of boundary layer is around 300 meters. So from the WRF model, the wind speed at boundary layer top is around 60 or 70 meters per second. So within urban districts, in some region, the simulations indicates that the maximum wind gust is comparable to the wind speed at the boundary layer top, which is significantly higher. Then the lower left panel shows the animation of the airflows within urban districts in Osaka City. So you can see that there are some regions which experience very significant wind speed. And this fluctuating wind, turbulent wind, are affected significantly by building height and building distribution. As I showed in the previous slide, with the variability of building height, the maximum wind speed becomes higher because of the vertical momentum transport from the upper level toward the surface level. That kind of momentum transport will lead to the maximum wind speed at the surface level. Now we are moving forward to include the stability conditions in our large area simulation. What I'm showing in this panel is upper two panel indicates the Osaka City building distribution, and the upper right shows the maximum wind speed under neutral conditions. And we show here in the left column for stable case and right column for unstable case. And the middle panel indicates the turbulent kinetic energy, the degree of the turbulence intensity. And the lower panel, two panel shows the vertical momentum transport. Color scaling are slightly different, but I would say that under stable cases, turbulent intensity is minimized or reduced, while under unstable case, turbulence intensity, turbulent activity is enhanced and strengthened, which will lead to the stronger wind gust. So this stability condition will be affect the gustiness. So we have also investigated how gustiness depends on urban geometry. The left panel shows the dependence on roughness density, while on the right panel shows the dependence on roughness height variability. So, if you look at the right panel, the wind gust will increase with the increase in roughness height variability. So again, this shows that the wind gust will be enhanced or strengthened with the increase in roughness height variability or building height variability. And this enhancement is strongly appears under unstable conditions. And this is the summary of my talk. We focus on the large area simulation technique to be used for risk assessment of meteorological disasters. So in order to assess the risk in urban districts, we somehow consider worst case scenario and assessing the impacts of climate change with dynamical downscaling, like a pseudo global warming experiment. And we use the work model and building resolving large area simulation model downscale from regional scale, city scale, and district scale, or maybe used as airflows over complex terrain. That kind of downscaling will provide quantitative estimation, and this estimation can be used for climate change adaptation and mitigation strategy. Okay, and I think this is all I have, and thank you for your attention.
Thank you very much, Professor Takemi. So nice presentation of the hazard estimations. I welcome many suggestions and comments or questions from the audience. Raise your hand or please start speaking. Questions? So I have questions to Professor Takemi. Can we consider the more heavier typhoon in this area or not?
In my talk, I haven't mentioned about the impacts of climate change, but if we consider the impacts of climate change, extreme typhoon will be more stronger under warmed climate. In that case, the external forcing should be more emphasized. For example, this wind distribution is scaled at the wind speed at the boundary layer top as a reference wind speed. If the reference wind speed becomes stronger due to the intensification of typhoon, we need to rescale the wind gusts in urban districts.
So that just suggests that if we have some information for the future typhoon, this tool can be applied to estimate the future disasters, right?
Yes, yes. Actually, I'm collaborating with Ministry of Environment, and they are interested in this kind of high resolution information to be used for climate change adaptation in urban districts. And also stability condition will be different in climate change condition, warm climate. So coupling with roughness information as well as stability information will be used for quantitative estimation of wind hazard in urban districts.
Okay, thank you very much. Other questions or comments?
May I ask you a question, sir?
Please go ahead.
Question is that you run the work model and less models with 4.5 kilometer and 900 kilometer for soil domain. But what is the data resolution, sir?
What the data for building data?
Yes.
Building data has a 2-meter resolution, and this information is not freely available actually. And some companies, GIS company, geospatial information company will create this kind of products in urban districts. So if we have this kind of high resolution information of buildings, we can use this technique to quantitatively estimate the wind hazard in urban districts, not only in Japan, but also in other big cities in the world.
Okay, thank you, sir.
Thank you very much.
Okay, it's up to time. If someone have short questions. Oh, Taslima Iman-san. Taslima, okay.
Imam-san.
Iman-san, does anyone have some questions? Okay, no, thank you very much, Professor Takemi.
Thank you for inviting me.
Okay, so we are going to the next presentation. It's from Dr. Samarendra Karmaka. And it's a research on the highest temperature. Please go started, Dr. Samarendra Karmaka.
Yeah, thank you, Mr. Chairman. Thank you very much. I am here, but I have some problem here. There is no current here from 9 to 4 p.m. today. So it is very difficult for me also, but now I'm going to share the screen. Okay. So,
Seen clearly.
Yeah, it's coming. Yes, it's good.
Good. Okay,
Good.
thank you.
Yes.
Then I have to go.
Can you change the display to the presentation mode?
Hey, okay. Now you can see. Is it okay? Presentation mode is there. So the title of the paper, climatology of pre-monsoon and annual maximum temperature and the trends, along with associated larger scale circulations in Bangladesh.
Excuse me, sir, your slide is not moving.
Slide is not moving. Is it moving?
No.
No, go
Here
to
it
the
is.
presentation mode.
I went to the presentation mode. You see, this is moving. So this is the previous one and the previous one. So this is the title. You have, can you see my title?
I'm sorry, your slide is not in the presentation mode. So please shut off your presentation mode, and then do your presentation in the editing mode.
It is in the presentation mode already.
And please try to change the slide. Okay, it's moving now.
It is moving now.
Okay.
Moving?
Yes.
Okay, thank you. Thank you very much.
Go back to the first slide.
Okay, I'm going. Is it okay now?
Oh, now the slide 4 is showing. Can you show the slide 1?
স্যার আপনার স্লাইডটা মুভ হচ্ছে না, আপনি কি ওই স্লাইড শো মোডে গিয়ে 1 নম্বরে যান স্যার। Dear
Hello,
Chair,
do you hear me? Hello, do you hear?
We are hear you, yes. We are hearing you clearly, but your slide is not moving. So would you like to present later, sir? We will go to the next presenter.
Okay. So please try to, okay, we are going to move to the next presenter. Please check your Professor Dr. Kamaka, please check your presentation and do it later. So we shall move to the next, I wish the next speaker to start. And can you, are you ready? Dr. Afuruza Shurutana-san.
Can you hear me?
Oh, yeah, can you present now?
Yes.
Okay, we move on to the presentation by her, the temperature and precipitation projection over Dhaka division. And okay.
My screen is visible?
Yes, now it's okay. Please try to the presentation mode. It's moving now. It's okay, I think. Yes. Okay, please start.
Respected chair.
Yes, it's okay now.
Respected chair and co-chair.
Yes.
Assalamu alaikum. Today's my topic is temperature and precipitation projection of a Dhaka division of Bangladesh using Codex South Asia domain data. I am Afuruza Sultana, assistant meteorologist, Storm Warning Center, Bangladesh Meteorological Department. Outline of the presentation. The background of the study, objectives, data and methodology, result and discussion, and finally conclusion. Background of the study. In this study, Codex data are used. Coordinated regional climate downscaling experiment that are calculated using a regional climate model by dynamic downscaling, while global climate model is used to embed the domain in a situation global climate. In climatology, the coupled model intercomparison project is a collaborative framework designed to improve knowledge of climate change. Representative concentration pathway is greenhouse gas concentration or emission trajectory adopted by the IPCC. The four pathway RCP 4.5 up 2.6, RCP 4.5, RCP 6.0, and RCP 8.5 are used for climate modeling and research for the IPCC assessment report in 2014. In this study, RCP 4.5 and RCP 8.5 data are used for projection objective of the study. To observe the changes of temperature and precipitation over Dhaka division of Bangladesh, to calculate the rate of temperature and precipitation change over Dhaka division, to find out the future temperature and precipitation scenario of Dhaka division. Data and methodology. In this study, the two regional climate model are used. One is regional climate model version 4, which is developed by the Canadian Earth System Global Climate Model, which is derived by Indian Meteorological Institution for South Asia domain, and another is regional atmospheric climate model version 4, which is developed by Meteo France's global climate model, which is driven by Swedish Meteorological Institute for South Asia domain. The resolution of both model is in 50 kilometer. In this study, base year is counted for 1976 to 2045. Projection year is 2070 to 2099. For BNB station data of Dhaka division are used, and this selection level is mean temperature and Mantental test and Scansclub estimator. The Mantental test is a non-parametric test for identifying the trend of significance, positive or negative, in the time series. Scansclub estimator is a non-parametric procedure for estimating the magnitude of a time series trend. For bias correction method is used. Resultant discussion for temperature analysis. Monthly mean temperature cycle of IITM model is higher than SNHI model except February to May. For annual temperature, both model is increasing trend and IITM model is higher than SNHI model. Both model are statistically significant. The rate of temperature change is IITM model is 0.392 and the rate of temperature of SNHI model is 0.024. Upper and lower limit of sense slope estimator at 95% interval is 0.029 to 0.0517 and the upper and the lower limit for the SNHI model is 0.060 and 0.0376 at 99% interval. For IITM model is 0.0187 to 0.0566 and the SNHI model is 0.035 to 0.04556. For future projection is the monthly temperature for IITM model. For RCP 4.5, IITM model is higher than the SNHI model, and RCP 4.5 is higher than RCP 4.5 for both model. For annual temperature, both model are increasing trend. The change of temperature for IITM model is 1.8 and 1.83. For RCP 8.5, the rate of temperature for IITM model is 3.11 and SNHI model is 3.16. A comparison of observed data and simulated model simulated data. For monthly temperature, observed temperature is higher than both model temperature, but the temperature difference is very close. But annual temperature, the temperature difference from observed temperature is very high than model temperature. How to remove this error? I done bias correction by systematic bias correction method. After the bias correction, for bias correction, the monthly mean temperature for model temperature and observed temperature are very close without May to March to May. And for an annual temperature model of the model temperature and observed temperature are very close. Temperature projection for RCP 4.5 and RCP 8.5 from 2017 to 2019 in our division of Bangladesh. For RCP 4.5, IITM model shows decreasing trend and the rate of change is minus 0.03.
You have 5 minutes more.
Minus 0.032 and SNHI model is show increasing trend and the rate of temperature change is 0.0137 per year. For RCP 8.5 both model shows increasing trend, and the rate of change of temperature for IITM is 0.0479, and the rate of temperature for SMHI model 0.0274. For monthly precipitation for IITM model is less than SMHI model, and for annual precipitation shows both model is decreasing trend, but not significantly. For future projection, the precipitation change for IITM model is minus 11.02, and SMHI model is 6.46. For RCP 8.5 IITM model is minus 5.16, and SMHI model is 13.5. Finally, conclusion. Temperature both models shows significantly decreasing trend. The rate of temperature in decrement is minus 0.0392 degrees centigrade per year for IITM model, and 0.02 degrees centigrade for SMHI model during 1976 to 2005 at for RCP 4.5 after my study. Temperature of IITM model follows the decreasing trend, and the rate of decrement is minus 0.003 degrees centigrade per year, and SMHI model follows increasing trend, and the rate of temperature change is 0.013 degrees per year. For RCP 8.5 after by of IITM trend, and the rate of temperature change is 0.0479 per year. For SMHI model follows increasing trend, and the rate of temperature change is 0.07 per year. For precipitation, follows decreasing trend, but not significantly. For IITM, the rate of precipitation is minus 9.55 degree 559 millimeter per year, and for SMHI, the rate of precipitation is minus 2.61 millimeter per year during 2005. Thank you, sir.
Okay, thank you very much for your presentation. Does anyone some questions or comments? Please.
There is not. I may ask her a question.
Please.
Afroza, I have a question that both model you showed that temperature is increasing, but precipitation is not. Precipitation is decreasing. But my question is that how you will understand that it is statistically significant or not?
Okay, please. So you mean the seasonal difference? Yeah, this one. Yeah. This maybe this difference.
Afroza?
Yes, sir.
Temperature is increasing statistically significantly, but how you will understand that it is statistically significant?
If P value is greater than statistics, then it is.
It depends upon the Z score?
Yes. It's depend upon P value.
Okay. Thank you very much.
Yeah, I am Ishikawa. I have a suggestion on these issues. So looking at these figures, the temperature is lower in SMHI. I remember that the precipitation is greater in SMHI from June to November. So that suggests that more precipitation leads to the more soil moisture, which results in the lower temperature. So that was my understanding from your presentation. Do you think it's right?
Yes.
Okay. Takemi Sensei, you have some questions?
Hi. Thank you. Thank you for your presentation. I would like to ask about bias correction. How did you perform bias correction for temperature, and also have you correct biases of precipitation?
I used systematic bias correction method.
So you correct biases in terms of monthly average.
Do you have answer?
Sorry.
So the question is that what is the difference of bias correction on monthly average, or possibly in annual average, or something else?
A monthly average.
Okay, thank you very much.
Thank you.
So
Thank you, Apraja.
Thank you, sir.
Other questions? Okay, so if you have a question, please raise it in the final the discussion time. Okay, so we go. Can I go back to the second presentation by Dr. Kamarka?
Yes, he messages that he is okay for.
Okay.
So he's okay now. Okay.
Okay, please.
Actually,
Number 24.
I think my paper will be shared by Mr. Shodav. Okay.
Okay, yes, it's okay.
Thank you. Thank you. Now I have. Should I start? Do you hear me?
Yes, I can hear me.
Thank you, Chairman. I'm sorry. It is because of some technological problems. You know, actually, hello.
Hello.
This work, the screen is lost.
Yes, it's now.
Yeah, this work has been done jointly with Dr. Mohan Kumar Das. He is one of my colleagues also. So next, please next.
Afroza, mute karo, Afroza.
Yeah, some sound is coming. Actually, I want to give a short introduction. It is well known that Bangladesh is a playground of different types of weather because of its geographical location, having the moisture reservoir like the Bay of Bengal in the south and the Himalayas in the north, with the large continental areas in the west and the east. The different types of weather which hit the country are heat waves, heat stays, drought, cold waves, cold stays, dense fog, nor'westers, tornadoes, tropical cyclones, and associated storm surge with heavy rainfall during flood, monsoon floods, and also flash flood occurs in this country. And the weather phenomena affect human being and natural ecosystems of these heat stays with highest maximum temperature has profound impacts on human being, especially elderly people and the children, causing discomfort and health problems, and also on agricultural crops. Next, can you increase the slide, make it large, a little large. Showed up.
Sorry, sir, this is slideshow mode. We cannot zoom it out.
Oh, but the letters are so small. Okay, next slide. With the increase of temperature, people may feel increased irritability, loss of concentration ability to do mental tasks, loss of ability to do skilled tasks or heavy work, loss of human lives also occur. The present study actually deals with the climatology of pre-monsoon and annual maximum temperatures. There are trends with possible large-scale atmospheric conditions causing intense maximum temperature in Bangladesh. Next. Data in the study on maximum temperature for the months of January through December for the period 1981 to 2016 at 34 stations of Bangladesh Meteorological Department are used to study the climatology of pre-monsoon and annual maximum temperature. The trends in Bangladesh. The stations are shown in the figure, and also NSF, data for the March to May for 2014, especially for 1 year, has been used. Next one, next please, has been used to study the larger scale atmospheric conditions which have been simulated for the year 2014, and 2014 is selected because during the period of study, actually this year had a longer period of heat waves, and also maximum temperature greater than 36 degrees Celsius was the highest frequency in this year. That's why this year has been studied. Next, and the next results. Next one. And this is the distribution of monthly and seasonal mean maximum temperature during the pre-monsoon season over Bangladesh. We see here the distribution, okay, and the distribution patterns of monthly and seasonal are almost similar here. The highest maximum temperature, both monthly and seasonal temperature, is over the central western part of the country here. This part, actually maximum temperature occurs. The lower mean maximum temperature over the Rangpur and Mymensingh region here, and Rangpur is here and Mymensingh is here. There is the lower mean maximum temperature occurs. Secondary lower mean maximum temperature occurs over the southern part of Bangladesh near Hatia and Sondip Chittagong region, this region. Okay, so next one. Highest and lowest mean maximum temperature are as follows, as per the month. Highest maximum temperature was 33.4, that is the mean temperature, that is over Jashore and Chuadanga, that is in the western side. Lowest maximum temperature is 30.6 degree over Rangpur, Mymensingh region, and in the southeastern part of the country, Chittagong hill tracts, and the mean maximum temperature is 32.4 degrees Celsius. The mean maximum temperature in the central Bangladesh ranges from 31 to 32 degrees Celsius. In April, highest maximum temperature is 36 degree or more over western Bangladesh. Lowest one is 32 degree over the region of Rangpur Mymensingh region, and mean maximum temperature over central part is 33 to 34.5 degrees Celsius. And in May, the highest maximum temperature is about 5 degree all over the is lower by about 5 degrees centigrade all over the country. This lower mean maximum temperature may be due to the increased thunderstorm or rainfall activities and due to the advancement of southwest monsoon towards Bangladesh at the end of May. But in the in this context, I must say that the extreme maximum temperature practically in the history of Bangladesh normally occurred in May in perhaps 1968 or 72, something like that. However, in this month, highest maximum temperature is 35.5 degrees Celsius or more over the western part, and the lower mean maximum temperature is 32 degrees over the northern part, and mean maximum temperature 33 to 34 degrees over the central part of Bangladesh. Next. Seasonal one, the highest seasonal mean temperature 35.0 degrees over the western Bangladesh. Lowest seasonal maximum temperature is less than 31.5 degrees over the southern northern part, and the mean maximum temperature 32.5 degrees is found over the central part of the country during the pre-monsoon season. And normally during the pre-monsoon season, the maximum extreme temperature occurs over the country and in the month of April and May. About the annual mean temperature, it is here also. We see that the annual mean temperature is also maximum on the western side. The highest annual mean maximum temperature is about 31.6 degrees. That is over the western part of Joshua-Chuadanga region here. Lowest annual maximum temperature is 29.8 degrees Celsius over the Rainfall region here, and the annual mean maximum temperature ranges from 36.6 to 31.0 degrees over the central part of Bangladesh. And it is apparent that the seasonal mean maximum temperature during the pre-monsoon season is about 4 to 5 degrees higher than the annual mean maximum temperature. Next. And we see that is the places of mean maximum temperature. The highest maximum temperature is about 30.5 degrees Celsius over Chuadanga here, and second one is the 34.4 degree over Rajshahi, okay, and then lowest minimum one is 31.1 near Madaripur, that is in the central part of Bangladesh. And the annual maximum temperature, annual mean highest temperature is 31.8 degrees Celsius at Jashore, that is in the western part. Second highest maximum temperature is 31.6 degrees Celsius at Chuadanga, and lowest annual mean maximum temperature is 29.6 degrees at Rangpur. Next. Trends in the monthly and seasonal mean maximum temperature during the pre-monsoon season in Bangladesh. Actually, the trends in monthly and seasonal maximum temperature are computed graphically through temporal variation of the data at all 34 stations during March to May 1981 to 2016. The significant test of the trends values are done with the help of error distribution test. And in March, we have found that the mean maximum temperature has increasing trends at 31 stations out of 34 stations, that is 91.2% stations in Bangladesh in the month of March. And the rates of increase in the maximum temperature are statistically significant, 95 to 99% at 15 stations, mainly in the coastal stations. The maximum rates of increase are 0.086 degrees Celsius per year and 0.082 degrees Celsius per year at Sitakundu and Sandip respectively, and these rates are significant at 99% level of significance. Next. In April, maximum temperature has increasing trends at 27 stations out of 34. The rates of increase in mean maximum temperature are statistically significant at 16 stations. Maximum increasing rates are 0.081 degrees Celsius per year and 0.075 degrees Celsius at Majdi Port and Sitagundu, that is in the eastern or southeastern part of the country. May maximum temperature has increasing trends at about 33 stations out of 34. The rates of increase in the mean maximum temperature are statistically significant at 15 stations. The maximum increasing trends is 0.067 degrees Celsius per year at Majdi Port. And seasonal temperature seasonal mean temperature, you see maximum temperature increasing at all stations. The rates are statistically significant, 95 to 95.9% at 16 stations, especially at the coastal stations. And maximum increasing rate is 0.072 degrees Celsius per year at Shonde. Next. The next figure gives some diagrams showing the trends of the maximum temperature, especially in the divisional stations of Dhaka, Monsoon, Rangpur, then Sylhet, Borishal, Chittagong, like this. So next, we see all in all the stations the temperatures
Excuse
are
me, sir,
increasing.
5 minutes more.
Okay, next. Increase in maximum temperature is found that the mean maximum temperature has increased by 1.1, 1.2, and 1.3 in March, April, May from, whereas the seasonal mean maximum is increased by 1.2 degree during the period that is with respect to the 1981 in up to 2016 over Bangladesh. Next. Trends in annual maximum temperature is also increasing at about 33 stations, and the rates are statistically significant at 28 stations. The highest increasing rates is 0.59 degrees Celsius is found at Shonde, and the coastal station where the coefficient of emission is 78.1%. Next. And these are the same stations, that is the annual maximum temperature trends. Next. Next. That is the country average annual mean maximum temperature, and it shows it is also increasing at the rate of 0.05 degrees Celsius per year. And if we calculate the increase in temperature, maximum temperature, it is found that 1.5 degrees Celsius in 2016 with respect to 1981. Next. The distribution is almost similar with some little differences, and the maximum is here, and maximum rate, that is the distribution of the rates of increase of maximum temperature. It is here in the central part and also in the Sylhet region. Next. And these are the, some atmospheric conditions simulated during the mean sea level during the period, and this is the mean sea level distribution. Here we see in March there is normally higher pressure domination of the subtropical high. Next one, and here no, it is the previous one. Yeah, here the pressure fall, there is a little pressure fall, but in May, I think pressure fall is more than the May and April and March. Next slide, please. That is the geopotential height. Here also we see the dominancy of the higher geopotential, geopotential height over this region, but in May, I think it is less in this month, and because of this, influence of the subtropical high, I think the temperature is much more during this season. Thank you. That is the monthly mean specific humidity. If you see the specific humidity at 1000 hectopascal level in the pre-monsoon season, we see the that is the year of 2014. The specific humidity is only 4.5 to 9 gram per kilogram over India and Bangladesh, and the maximum over the oceanic areas and the minimum over the land areas, except South Asian countries, Philippines, Malaysia, and Indonesia. Moisture begins to increase over the land areas as the season progresses. Next. And this is the cross-section of monthly mean vertical vorticity during the pre-monsoon season, and we found that the downward motion, that is positive vertical velocity, exists at 650 to 100 hectopascal level over Bangladesh and India, with the maximum value of 0.0, sorry, previous one, 0.08 Pascal per second, and with the hello.
Time is almost over.
Okay, just 2 minutes. 2 minutes. Give me 2 minutes. Just to show the next slide. Okay, that
Okay.
is the atmospheric flow patterns. Although it is not clear in the slides, here practically we see during the pre-monsoon season, mostly, you know, the winds are from west to northwesterly, both at 850 hectopascal and you know 850 and 300 hectopascal. So these are practically responsible for the advection of maximum temperature from the heat low areas over India and Pakistan, which happens during the pre-monsoon season and with the advance of the monsoon season. So the westerly winds are mainly responsible. But sometimes, you know, when the thunderstorms occur at the time, some westerly trough also advances, but the year in which the westerly wind and the influence of the subtropical high is higher, that year I think we get the maximum highest maximum temperature and extreme maximum temperature in that year. Thank you very much. I think I'm not going to anymore to show the conclusions, because the conclusions are already within my presentation. Thank you very much, Chairman.
Thank you very much. We can accept several few questions or comments. Does anyone have raised a hand? Or just start to speak if you have questions. Okay, Shaila-san, please. Shaila-san, please. Okay. Shaila-san is raising a hand. You can start. No?
Probably no.
Okay. So that some other guy has questions or comments?
Yes, I have one question, please.
Please.
I'm Dr. Azam. Thank you so much, Dr. Samaranta Kormakar, sir, for your nice presentation. I have just very basic question to know from you, is that like about the distribution of rainfall in Bangladesh, like in different districts have the like some nearby district have the high precipitation rate, rainfall rate, but besides there some area have very low precipitation. So why the difference is very high? What is the mechanism behind this?
Practically, it depends on the flow patterns of the monsoon. Normally, we get the highest rainfall over the northeast and also the southeastern part of the country. In the northeast, because during the pre-monsoon and monsoon season, normally we have the orographic effect, and most of the time the winds are, you know, converges in the Sylhet region, that is northeastern part, and in the southeastern part, that part gets the highest impact of monsoon there. So monsoon rainfall is higher over the Chittagong region, that is southeastern part, and the annual rainfall is higher over the Sylhet region. And in this western side, practically the rainfall is lower than the eastern or central part of the country. It is because of the monsoon flow pattern and depends on the axis of the monsoon. Thank you.
Thank you, sir.
Any other questions? Mr. Chairman, thank you very much. If there is no question.
Thank you, sir. Thank you. Thank you very
Thank-
much.
Okay,
Thank
we
you,
are going.
Dr. Molly.
I'm sorry, I muted my mic. Okay, we are going to the next session, please. So the
Okay,
next
thank you. Thank you very much. Thank you.
and the next presenter is Dr. Shahana Islam. This is a study with CMIP6 data. Okay, please start. Dr. Shahana-san, could you start?
Are you hearing Shahana Islam?
Yes, I can hear you. I don't know. Shahana-san, Shahana Islam-san.
Probably we have to go next on, sir. Probably she is not available.
Okay, so that we move on to the next presentation. Number 26. Dr. Shaira Akhtar-san. Dr. Shaira Akhtar, the presentation number 27.
Yes, session chair. I will present on behalf of her.
Okay, please.
Yeah.
Okay, Dr. Azam, thank you.
Okay. Okay, it's coming.
Can you see the slide? And
Yes.
my voice is louder.
Yes.
Okay.
Respected session chair of technical session 5, Professor Dr. Ishikawa-san, and co-chair Dr. Mollik, and distinguished experts and dear audience, Assalamu alaikum. And now it is, I think, still good morning. Myself, Dr. K.M. Ajum Chaudhary. I am an assistant professor of the Department of Oceanography from University of Dhaka. Title is seasonal and long-term seasonal sea level variations and their forcing factors in the Northern Bay of Bengal. The outline of the presentation is flashes in the screen. So basically here I will talk about the seasonal and the long-term sea level variations and their forcing factors in the Bay of Bengal. How about the study area you see is the Northern Bay of Bengal is part of Northern Indian Ocean. So the Bangladesh lies where so many river channels are there, and Ganges, Brahmaputra, and Meghna river system is the 4th largest river discharge, and also during the monsoon there is a huge rainfall. So if you see the salinity distribution of the Northern Bay of Bengal, you can see this region is very fresher and salinity is very low. So this causes the haline contraction, and which obviously impact the steric height of the sea level. If you see the temperature distribution, like the SST distribution in the tropical and subtropical region, yes, obviously warm SST is there, and that obviously influence the steric height of the sea level due to the thermal expansion. And also, if you see the wind system, there are two kinds of wind locally, like during winter, the northeasterly, and monsoon, there is a southwesterly wind. Even in the equator, there is a windkey jet. This wind also influence the local region of the Bay of Bengal through different oceanic processes like and the Kelvin, Rossby propagations, and change of thermocline and changing the temperature and sea level. So wind is also important for sea level study. If you see the global sea level distribution, obviously sea level is not uniform in the ocean. Like somewhere is very high and somewhere is low. So if you see the trend of the global sea level, yes, it's increasing rapidly with a rate of about 3.4 millimeter per year. And you see by the SEC report of 2021, sea level may rise by 50 to 100 centimeter by 2100. So it's very alarming. So who controls the sea level? So I say that thermal expansion due to global warming is an important factor, and also the haline contraction from the freshwater, from the rainfall, river, even melting of glaciers, and ice melting from the Greenland, Antarctica. So many sources that provides the fresher water, more water in the ocean. At the same time, wind stress current also have some influence due to the convergence of or divergence of the water masses. And besides, there are so many geological factors also involved to change the sea level, like the continental collision, sedimentation, subsidence, safer spreading, and groundwater extraction. So many things are involved. So here, basically, I will focus on the mechanism like the thermal expansion, haline contraction, and the influence of the wind stress curve in today's presentation. If you see the coastal area of Bangladesh, see in the most of the area is very exposed to sea level rise, and here is a low-lying country. And according to the IPCC report, we can see that sea level may rise even up to about 59 centimeter by 2100. And by 2050, it may rise up to 30 to 50 centimeter. And most of the cultivable land will become the salt marsh and will be under water if sea level rises by 1 meter. So this is a very important issue for Bangladesh, even though study is not enough for the sea level rise. And most of the study uses some of the scattered tide gauge data sets. And seasonal sea level is very important, like for coastal flooding and coastal ecosystem and for the overall environment. And you know that the coastal the Bay of Bengal, northern Bay of Bengal have the very shallow continental shelf. The coastal area have the funnel shape and is extremely exposed to floods. And seasonal study, I see that only one study by Khandakar is found here, and he used some tide gauges and even did not explain the mechanism behind why sea level is high or low in different seasons. And there are some study about the trend of sea level long term, but still the controlling mechanism is not concrete here. And you know, there are some study who says the climate variability like the ENSO and in El Nino, La Nina and Indian Ocean dipole, they have some relationships with the sea level in the northern Indian Ocean, even in the greater Bay of Bengal. But still, we are not clear about what about the coast of Bangladesh or the northern tip of the Bangladesh. So with this, here we have investigated the trend of sea level along the northern Bay of Bengal using AVISO and the tide gauges data sets. And we try to study the seasonal and long-term variations, and we try to quantify the mechanism behind the sea level rise here, and also the relationships of the ENSO and ID from both tide gauge and alternative data sets. So I said different data sets from PSMSL, tide gauge data sets, satellite data from AVISO, and reanalysis data sets, and some atmospheric data sets are used. And for the climate index, we use data from NOAA and JUMSTEC. And we define the season like winter, and spring is the pre-monsoon, and summer is the monsoon, and autumn is the pre-monsoon. And we calculate the stake height in the equation. The first part you see this equation calculates the thermal expansion, and the last part calculate the haline contraction for sea level rise. And we calculate the ocean heat content, and we use different methods, statistical methods and empirical orthogonal function analysis to make some relationships with different parameters. So we have seen my study area is divided into 3 regions: the western coast, central, and the eastern. And here, as a proxy, we use the tide station Huron Point, and here the Chorchanga and the Cox's is used. And in the offshore, you see the one blue circle is the Ramabui, is the permanent station. They are also providing different data sets. We use this to study. So grossly, if you see the base mean sea level, we can see from the left side, yes, during the winter and the early spring, sea level is low, and from late spring to summer and even autumn, we see sea level is high. So about the mean sea level, here we compare the mean sea level with the steric and with the thermosteric due to temperature, and helosteric due to salinity, how they contribute to the mean sea level, and we see the relationships. And we also see the relationships with the temperature, windfall, and the salinity. So in summary, you can see that from spring to summer, thermosteric component follows the static sea level, and from autumn to winter, helosteric component influence the sea level. And if you see here, we do some empirical orthogonal function analysis. So the first row is the mean sea level, second one is the thermosteric sea level, third is the helosteric, and fourth is the wind stress curve. If you see the first column is the first dominant mode, and we see that the coastal area have the high variability. And if you see the thermosteric have the very nice correlation, and also helosteric and wind stress curve have the correlationships in the coastal region. And we see that thermosteric component contributes almost 50%, and helosteric contributes like 23%. And wind stress curve is also have a positive correlation, especially in the autumn season. And there is also some UF analysis. Especially here, you see the first one is the mean sea level, and the SST, the sea surface salinity, and other parameters also there. And we see that SST have a strong pattern and strong temporal relationship even throughout the year. Like in the winter, SST is cool, sea level is low, and summer we see this high SST and sea level is high. So SST is very crucial, it's very important. And salinity also have relationships like low SSS is associated with high sea level during summer to early winter. We also see some relationships with the SST and sea surface salinity, even in the surface above 80 meter, above 150 meter depth, and above 900 meter depth. And we see that, yes, SST have a good correlation with the sea level and positive correlation, and sea surface salinity have the negative correlation with the sea level. And we can say that if we study the SST and SSS, they can be used as a proxy to see the thermosteric and helosteric sea level in this region. If you see the long-term variability, like is from altimetry data sets, you can see the sea level is increasing, and from tide gauges stations also see that it's increasing continuously. And if you see the region, the western, central, and eastern region, you can see the central region has the high sea level rate.
Ajam, you have
yes
5 minutes more.
Okay, and then I skip these slides. And you see the internal relationships. So different parameters have the relationships. So we see that if from figures, if heat flux is increasing the SST, is increasing the ocean temperature and heat content, and finally sea level is rising. And for the heliocentric case, we see the decreasing trend and increasing trend of both salinity and SSS is also observed. And obviously this increasing trend of salinity is actually due to the intrusion of salty Arabian Sea water recently is observed here. And in some case we see the precipitation is increasing, but the increasing rate is not much higher in this ocean. So here also we see some relationships. In summary, you can see that thermospheric sea level, yes, these have a strong relationships, like with 100% confidence level, we see that 0.45 relationships. And but we see the haline effect is plays the very smaller role, and wind stress might retard the long-term sea level in this basin. And we also see some thermocline variability have the sea level have some relationships, and even in the equatorial remote wind have like 36% contribution to the inside the Bay of Bengal. And some other studies they say that turbulent eddying process also have some contribution to the sea level. And about the relationship with ENSO and IOD, we see that even in the coastal region and northern Bay of Bengal, we see some relationship like sea level high during the combined event of La Nina and negative IOD year, like even in 98, 2010, and 2016, we see high sea level is related to the La Nina and negative IOD, and is also opposite during the El Nino positive IOD events. And I'm skipping due to time constraint. We see the mechanism. Basically, wind plays the role, wind anomaly, and who change the thermocline depth. And thermocline is obviously related to the static component of the sea level. So this is the summary. And finally, I said, yes, sea level is rising, and our rate is more higher than the global average, and higher in the coastal region. And we see this highest sea level found in the autumn season, and the contribution is come from the thermospheric and a little from heliocentric. And obviously temperature plays a major role, and remote wind also have a contribution like 36%. And we see the positive relation of sea level with the La Nina. And this study provides a groundwork for the future model study to see the sea level here. And you know, this very common impact, salinity intrusion is the very severe in the coastal region. And obviously we have to do some adaptation, like salinity tolerant plants needs to place here, mangrove plantation, and so many things we need to do. And obviously, as a mitigation, we need to raise the river bed. We obviously have to settle a big water reservoir to preserve water for the dry season. And obviously, environmental law should be enforced strictly. And bilateral and multilateral treaty and negotiation is important. Like for the river water discharge, we need some negotiation with the neighboring countries. And that's all for today. Thank you. Thank you so much.
Thank you very much. So very nice presentation from the ocean sciences. Does anyone have questions? Raise your hand or speak by yourself. So I have one question. So you say that,
yes, sure, you can.
Okay. You have the sea surface temperature SST and salinity SSS has major control, but I think both affect the density of sea waters. Can you compute the density, change of density from those informations?
Yes, obviously I can compute the density. Basically, if you see our method here, I explain the method. So here you use the steric effect, right? So
Okay.
for the steric effect, actually we calculate the density of the volume here. So ultimately we see that yes, thermosteric component have the great impact compared to the halosteric component. So that's so
and,
yeah.
And so for the ocean heat content, do you how do you compute this value from?
We compute this from time series daily data sets and also some reanalyzed data sets here. The N4 this is one degree grid data sets, and also the Rama buoy, they have the temperature of the ocean, and for the calculation you see the equation. So we use upper 900 meter from surface to 900 meter. We calculate the ocean heat content using this equation, right?
But I suppose the depths of how is the depth of the sea bottom in the northern bay of Bengal?
Oh yeah. So for because my study area have some deeper ocean and some shallow ocean. So if their ocean is shallow, then I use the water column, maybe 10 meter, 15 meter is okay. And if there is a higher depth, then I have taken only 900 meter.
Okay, thank you very much. I think there is difficulty in that area because of the shallowness of the sea bottom.
Yes.
Does anyone have questions? Okay, thank you very much. So for the next speaker, can I go back to the Shahana-san? Dr. Shahana, are you ready?
Sir, she is ill, so she will not present today. So we can go to next presenter.
Okay,
already
I see.
She messages that she is very
ill. Jennifer Weeks.
Hello.
Yeah, okay. Please start your. Can you ready? Are you ready?
Yes. Can I check that I'm co-presenting with Saiful Alam?
Yes.
Could I check that Saiful is ready as well?
Can you hear me?
Yes. Can you hear me?
Yes, I am.
Oh, Saiful.
Oh, great.
Okay. Yeah. So hopefully, okay. Yeah, I can see.
Okay, please start. We can see your slide.
Okay, great. Okay, great. Hi, everyone. So my name is Jennifer Weeks, and I'm a climate scientist at the Met Office. So today I'll be talking about the work we've been doing on sea level projections for South Asia. And then I'll pass over to Saiful Alam from the Institute of Water Modelling, who will be discussing work on coastal dynamics in Bangladesh. So this list of authors is just a few of the people who have been involved in this work, but there's many more. So our work is being conducted as part of the ARC programme, which stands for the Asia Regional Resilience to a Changing Climate programme. So this is a 4-year programme which aims to improve the uptake and use of weather and climate information for decision making. So as part of this, we're working to develop coastal climate services with organisations in Bangladesh. And in particular, understanding sea level rise is really important since of course, sea level rise or sea level changes cause extremes kind of, they drive changes in extremes from kind of tides and surges. So in 2018, the UK generated sea level projections for tide gauge locations around the UK. And following this, my colleague Ben Harrison used these methods to generate sea level projections over the 21st century for tide gauge locations in the Arabian Sea and the Bay of Bengal. of which you can see on this map, and then kind of example projections below. And these were written up firstly as a report, and then more recently, in fact last month, they were published as a journal paper. So sea level change, as we've heard in the previous talk, it's a combination of multiple processes acting at different spatial and temporal scales. So on the global scale, we have the kind of effects of thermal expansions. So as the ocean warms, it expands and then sea level rises. But then also it's a combination of kind of water mass input into the oceans. So the input of kind of melting glaciers or ice sheets, changes in the mass of ice sheets. But then also changes in how water is stored on land and whether that's put into the ocean. So we refer to these kind of water mass changes as barostatic changes. And then this won't be distributed in the global kind of mean sea level change. It won't be even around the world. There'll be highs and lows, and this is due to the effects of ocean circulation and density, as in the previous talk, and we've referred to these as stereodynamic changes. But then also the way that the kind of land, ice, and water storage is redistributed across the globe varies due to the effects of gravitational, rotational, and deformational effects. And then on longer time scales, we have kind of the contribution to sea level rise from the movement of land due to glacial isostatic adjustment. So as ice sheets are removed, the land rebounds to compensate for this. So the projections I'm presenting include these processes at the global and regional scales, but they're not including the processes due to kind of tides, surges and waves, or the vertical land motion processes from local subsidence or tectonic movements. So yeah, that's just something to keep in mind, that I won't be looking at these kind of higher frequency processes. So as I mentioned, our regional projections are based on the methods of UKCP 18 and also the projections presented in IPCC AR5. So that's using the same Monte Carlo framework that was used there based on CMIP5 models. So what we do is we use maps or fingerprints, as we call them, of how the thermospheric and barostatic components vary across the globe. And then we combine this with the pattern of glacial isostatic adjustment. And then we account for stereodynamic changes by establishing regression relationships between thermospheric sea level change and ocean dynamic sea level change. And we do this at each of the tide gauge locations that we've selected. So their projections kind of produced at each tide gauge location. So how much geographical variation do we see in the future changes? So these are the projections for a low emission scenario. And you can see the projections at each tide gauge location shown in orange, and then we've included the global for comparison in blue. We've also included here observational records from tide gauges and satellite altimetry. So these weren't included in the projections, but they're just included here for comparison. And then the purple bar is showing the results of a recent IPCC report. And as we can see, in general, the sea level change is actually lower than the global at all tide gauge locations. And just to mention as well, these are compared to a baseline of 1986 to 2005, so that's the AR5 baseline. And then looking at the likely range, so from the 5th to 95th percentiles used in AR5. So if we look at a high emission scenario now, we can see here that the uncertainty range at the local level is greater than global projections. And also we can see that the sea level rise increases as we move further south. And this kind of, these plots show that you can't just rely on global projections for local planning and decision making. So what are the processes that are driving the future sea level changes and variations? So these bar plots are showing the component, like a component comparison. So that's relating to kind of the diagram that I was showing before with the sea level jigsaw. So what these are showing is that the Antarctic ice sheet dynamics component and also the land water storage component, so that's the ones kind of towards the right, they're causing the greatest spatial variation. And something to note is that kind of these are both, I guess, kind of being updated quite a lot in sea level research. So in particular, the Antarctic dynamic component is kind of constantly being revised as kind of there's greater understanding. So we used an updated estimate from the Leverman et al. Paper, but that's not including the processes of kind of rapid ice mass change. So from kind of marine ice cliff instability. And then kind of we had the land water storage, which we also used a revised estimate for, because it accounts for the fact that not all land water will just be input into the ocean. Some of it will be recycled locally. So why would land water storage have an effect on sea level change at the regional scale? So when large amounts of water are stored on land, they have a kind of bigger gravitational attraction to the water in the ocean nearby. And so near to this source, the sea level would be higher. But then as that land water is released, the gravitational attraction is less. So that causes the water in the ocean to be kind of pushed away. So the sea level near that source will be lower, but then that water has to go somewhere. So further away, the sea level will be higher. And if we look at the numbers, so these are showing the 5th to 95th percentile ranges, we can see that, as I mentioned before, the projected changes increase as you move southward, but then also they increase eastward along the northern coast. And this is only by a few centimeters, but it's due to kind of the increasing distance from these locations of area of terrestrial water storage mass change. So effectively, what we need to bear in mind is that it's really important to kind of gain a real grasp on what the contribution is to these tide gauge locations from land water storage change, because they have quite a few centimeters impact on the actual projected sea level change. So I'm just going to say a bit about how our projections compare to the recent IPCC's 6th assessment report projections. So in these plots, I show the our study changes in orange compared to the projected changes from shown in AR6. So the global changes are shown as the dashed lines, whereas our projections are shown by the solid. And we can see that there's generally good agreement between the global projections. However, we see that in AR6, the local changes, they have a lot more spatial variation. So for example, here in Point is actually above global average. So just looking at why this might be. So I've plotted here again, these are kind of bar plots showing the component contribution to sea level rise at each location under kind of a low to high emission scenario. And we see again that the Antarctic ice sheet component is kind of causing a lot of spatial variation, but in particular, the vertical land motion component is driving a lot of the spatial variation and also the uncertainty. And this is due to the different methods used between our study and the projections produced by AR6. So in our study, we included vertical land motion from glacial isostatic adjustment only, which is what I showed earlier, whereas in AR6, they included vertical land motion kind of derived from a spatial analysis of tide gauges. So this includes all the kind of local land motion movements, such as subsidence and maybe tectonics as well. So this is really important for Bangladesh because obviously we have the association with the Ganges-Brahmaputra Delta. And this recent study showed that the rates of subsidence really vary across this delta, kind of from 2 to 20 millimeters per year. And this is on the order of sea level change, the rate of sea level change. So gaining a grasp on what the contribution to sea level change is from vertical land motion is really important. And local studies will really help with this. So this is just my summary slide, but I'm going to pass over to Saiful Alam from the Institute of Water Modelling. So just in summary, our projected changes are less than the global average. However, there's kind of active research in quite a few of the components and they contribute to a lot of the uncertainty. So for example, the Antarctic ice sheet component and the vertical land motion component, but then also the land water storage component. In particular, to monitor vertical land motion using GPS enabled tide gauges would really improve this understanding. So now I'll pass over to Saiful from the Institute of Water Modelling, who will be presenting on understanding sea level rise dynamics of Bangladesh along the coast. Okay, hopefully Saiful is there. Okay, I can't see Saiful actually in the meeting anymore. Might be having technical difficulties.
If he is not available, then you can proceed. Dr. Jennifer Weeks.
I'm not sure. Let's have a check. I wonder whether my colleague Ben might be able to say a bit about this study.
Jenny, just to interrupt, would you please contact Mr. Saiful, because I don't see him in the panelist or even in the list of attendees.
Yeah, I've contacted Saiful, but I haven't heard anything back. Hang on a sec. Okay,
Hi, Jenny. Did you want me to?
I wonder if you might be able to say a few words.
Yeah,
I don't think Saiful was able to connect.
Okay. So the Institute of Water Modelling are kind of aiming to kind of pick up in the areas where the Institute of Water Modelling aiming to kind of pick up on the areas that we haven't included in the projections. So these are the vertical land motion processes that Jenny mentioned, and one of the kind of constraints with that is what observational data is available and trying to kind of reuse various data sets that have been collected over the years. So things they're interested in is how does sea level vary for the different coastal zones? So a limitation of our projections is they apply to like the extreme coastline, whereas in Bangladesh the actual influence extends quite far inland, which varies through the seasons. So another thing they're interested in is the kind of seasonal changes in sea level, which we kind of heard a bit about in the previous talk. And I guess the practical motivation for this is how to kind of design new, upgrade existing sea defences and plan new ones that will be kind of robust across a range of changes and scenarios. So we go on to the next slide, Jenny.
I think I've just seen Saiful join.
Hello, Jenny.
Hello.
Okay.
Can you see me? Can you hear me? Huh?
Yes.
You can also
Very
see
clear.
me. So
yes.
So what we from Institute of Water Modelling in cooperation with UK Met actually trying to understand the sea level changes in terms of the very local processes like freshwater discharge into the bay from the GBM basin, and there is a seasonality in this flow, and also there is a very dynamic delta because of the sedimentation and the tectonic the changes. There is a change in the elevations, and also the morphological changes are happening. Land is developing gradually over the years towards the south, and this also causing some changes in the sea level. And we are going to investigate these things. And to do that, we have firstly examined 5 reference gauge stations, tidal gauge stations, which will represent the changes happening in the 3 coastal region, west, central, and the eastern part. Next. In doing so, we have determined the constituents and found that while in the eastern part, the tidal amplification is higher than the in the western part, and sea level rise is also found to be very small in the tidal fluctuation. I mean, the tidal amplification is quite high in the Rangadia, very close to the Chittagong. It shows very slow or flatter rise in the sea level according to the gauge tide, which explains according to the Patrick, that when there is a very high range of application, the relative sea life changes is also slows down, so is underestimated in a way. On the other hand, you see in the middle of the estuary in the Daulat Khan, where the huge monsoon flow enters, and you can see the rise is about 27 millimeter per year. It is based on the July data. So there's a real amplification of the sea level during the monsoon because of the freshwater inflow into the Bay of Bengal. Next. Next, Jenny. So I have compared this tidal gauge data with the satellite data altimeter, and which is the mean monthly average, the anomalies of the monthly average over the annual. So it shows also the rate of rise at the Chachanga, which is very close on the middle and central part of the coast, and which shows about 7.5 millimeter per year. On the other hand, the tidal gauge measured by BIWTA shows a double of it, and this is something to do with something we need to explore further. Next. Next, please. This is another point, which is extreme west, Huron Point, which has very consistent value of 3.7 millimeter per year by the altimeter records, and the gauge records also shows the similar kind of 4.4. As we will next, please. As we know that there is a tectonic changes in the delta region, and this causing the deformation of the ground surface, and which is greater in the eastern part compared to the west. And the Huron Point is somewhere where this changes due to the tectonic activity is minimum compared to the eastern side. And that could be some reason why with the altimeter and the relative measurement by the gauge, tidal gauge, shows quite high differences. And we like to use this data. So far been studied by different researchers, and use this data to have a reference tectonic deformation in 3 different coastal range to find out how it impacts the relative sea level in this and how to bring about the changes in the water management and the adaptation measurement being taken by the Water Resource Ministry and the Water Board, etc. Next. This shows the sediment balance, which is a huge amount from the Ganges, Brahmaputra, and Meghna basin. But out of 1.1 billion metric ton, only 0.2 billion is entered into the estuary to build up the land, and another 300.3 billion goes out in the subcuse fan in the Bay of Bengal, and only 0.1 million metric ton of sediment actually is pumped inside the southern part of the coast, which is mainly benefited by the Sundarban, which is quite raising gradually over the years. Next. And we have a plan, because our study hasn't finished yet, and still we have another year almost to bring about these data available in different publications, to bring about the net deformation due to the tectonics, and also the rise or fall of the for other purposes like the groundwater abstraction, if it's very significant in some part, and also the sedimentation that causing the rising of the water level. And then this is a hypothetical, a little bit, or conceptual, that the Sundarban part is compensating the rise in the sea level as it is gradually degrading due to the sedimentation primarily, and with minimum subsidence due to tectonic reason. And while the central part would be the most vulnerable one, probably because of the more subsidence and high level of sea level rise because of the freshwater flow. That is the hypothesis we are going to further investigate. Next. These are the two tidal gauge station water level, which shows the seasonality. About 1.5 meter difference is found between the dry monsoon and the winter. And we have to further investigate in more detail, which is based on the average, moving average of the tidal data. Next. Next, this shows the discharge that is incoming into the Bay of Bengal from the estuary, which is ranges about 50,000 to 1 lakh millimeter cube per second during the monsoon, and which again reduced to about 10,000 meter cube per second. So there's a clear fluctuation of the water level in the tide gauge because of these changes in the discharge, and that next, and that we are going to investigate further under different scenario of climate change. For that, we have to run several hydrologic model, the GBM model, where the rainfall, temperature, and precipitation are projected using the RCM data from the Cortex data, and which are properly bias corrected, and then we will fit this flow into the national river model. Next. National river model to generate the boundary condition in Bangladesh, one in Bahadurabad and one in Hardy Bridge, and another in the southern part, Amulshi. So this will be used. Of course, there are other inflows from the other part of the border, and the hydrodynamic model and the rainfall runoff model will be employed to generate the flows that is feeding into the Bay of Bengal. Next. The Bay of Bengal, next please. This Bay of Bengal will be forced by the boundary discharges from the river model, and of course the southern boundary condition will be given from the global wave model in terms of wind speed, atmospheric pressure, and one thing is important that we like to change the bathymetry over the during the future projection, considering the tectonic deformation and the sediment degradation and the land form changes along the estuary. This will probably make changes in measurement in the gauge data. Thank you.
Excuse me, time is almost over.
Yes, I am also over. This is the result of the Bay of Bengal, which will show the different rise in the sea level rise, and which is quite interesting that in the closer to the coastline, it is quite high than compared to the deeper sea. So the measurements we are making through the tide gauge is important, where it is located and what it is measuring, and it should compare with the global and regional sea level as well, to have a better perspective for the sea level rise around Bay of Bengal. Thank you.
Thank you very much. It is very impressive for me that the balance of coastline in northern Bay of Bengal is on the balance of the seawater, sea level rise and the sedimentation from the river, and also the change of the land surface height. Okay, so does anyone have questions or comments? Adam-san.
Yes, I have.
Adam-san, please.
Thank you, Jennifer and Professor Saiful Alam. Very informative, and I have so many questions. Actually, it will waste time, and maybe I will ask very few now, and next time I will contact with you for this. Very interesting. So Jennifer, I want to ask Jennifer, so for the projection, which model do you use?
So for the projections, we used the same 21 models, CBIP 5 models that were used in the 5th assessment report from IPCC. And then, like, as I was saying, we use yeah, according to that diagram, kind of the patterns of how sea level change, and then kind of the regression relationship between yeah, thermospheric and kind of dynamic sea level to produce like the stereodynamic component. So yeah, effectively we use the same CMIP 5 models that were used in AR5.
Yes, thank you. Next question to Dr. Saiful Alam. So it's very interesting. Like I have seen some subsidence rate you have shown. So how do you calculate this subsidence actually?
Well, in our
so far I know, yeah.
We are not going to measure the subsidence because we do not. We have to collaborate with other agencies to do that. We have will be using the all the data that have been so far collected by different researchers, and made certain validation using the tidal gauge and the altimeter, because the altimeter measures the absolute sea level rise, and the gauge tide measures the relative, and somehow we will be comparing these differences as in terms of the subsidence due to the tectonic deformation. And this is how we will validate and use this data. It will be a tentative one until we make a massive data collection and with GPS. And we have some program coming up with in cooperation with others in IWM for these purposes.
Yes, thank you. So yes, that is the other way to calculate the vertical land motion, just to make the difference from the satellite altimetry and pressure corrected tide gauge data. Just the difference between both of them gives the vertical land motion. Yes, that's the way. And I have other question is that for your model, I have seen the last few slides you are using the river model and maybe some other things. So which model you want to use for this study?
For the national region model based on the rainfall Mike 11 NAM model and the hydrodynamic 2D model, 1D model, and the Bay of Bengal model is 2D model. And these are the models we have been using for the water resource management, feasibility studies and all this. But in the next coming up projects, we will be adding more other sophisticated model with more detail in the ocean circulation and all these more parameters in the Bay of Bengal.
Oh, thank you so much. I am so much interested and looking forward your project. And the presentation I have presented today is already published in a journal, and it's also related to the sea level. And during that time, I saw there are so many lackings, like we don't have some data sets. Even in the PSML, MSL, we found that the year is different. For some station, the length of year is not comparable with the others. So it's a problem. And when we collect the data from the variability, we see that the reference level RLR is not calculated here. So we face some difficulties to use the PSMSL and the variability dataset because the reference level is different. So it's so challenging. And so I think
we need to cooperate with together to find out the ways.
Yeah. Thank you so much. I'm Dr. Ajum. I am assistant professor from University of Dhaka, Department of Oceanography. So maybe I'll contact you.
I'd like to contact you again.
Okay, Dr. Ajum, congratulations for nice question and interaction. You may ask later or communicate with Benjamin Weeks and also Professor Dr. Saifullah. Thank you.
Okay, thank you very much for your comment. So how is Dr. Sahana-san? Can he join us?
Sir, she is ill. May not.
Okay.
Present here. So
we can continue the discussion a little bit more, right?
Yeah.
If you have other questions, not only this presentation, but the questions and comment for the former presentation, we can accept it.
Okay, questions from the audience?
Yes.
They may ask. We have 10 minutes more.
Yeah, open to the audience.
Okay.
So we can have any questions or comments from the audience. No.
So may I ask a question to Dr. Azam?
Yeah.
Azam is here?
Yeah, yes, sure.
Mr. Azam, you have your research analysis is also interesting. You have shown that there is a strong relation with zonal wind, ENSO and La Nina.
Yes.
So, and have you did the correlation with sea surface temperature rising with IOD?
Yes. In fact, we have found this relationship with the sea surface temperature, with the sea level, and also the IOD. Maybe you missed the figure, and we see that yes, sea surface temperature is the dominant player here, still for the sea level. Yeah, and its relationship is very strong than other component.
Thank you, Dr. Azam.
For the Indian Ocean dipole, we see that La Nina and negative IOD time, we see the sea level is higher in the Bangladesh coast.
Okay. Is there any one-on relation?
Yes, the relationship is basically not totally independent. Like one parameter is dependent with the other parameter, So when temperature is changing, at that time water column is changing, like for stratification is changing. So it's not totally independent. But so far we tried to find some relationships. Yeah.
you, Dr. Azum.
Yeah.
Okay. So if there is no, Dr. Azam, do you have some answers from his questions?
No.
Okay. So it's a little bit earlier than the scheduled time, but if there is no further questions or comments, we can shut off. Maybe I have to give some conclusions. And okay, anyway, now in the Bangladesh, many research tools are available, I understand. You can use some models, also you have data. The CMIPS data is now available all over the world. So I think it's I appreciate you are starting the global warming related research in Bangladesh and surrounding areas. And as I say in the very early of these sessions, so the understanding of global warming is the first thing, but we have to understand what kind of hazard and disaster may caused by the global warming, and we have to prepare for the future disastrous conditions. So it will be a long way, but we have to continue to study and to cope with the global warming and change of environment. Okay, so thank you very much for gathering these sessions, and I wish your future great works, studies. Thank you very much.
So I want to conclude something. Doctor, yes, I want to say something. It is my pleasure to be here as a co-chair with chair renowned Professor Dr. Ishigawa-san. Here 5 papers are presented, including a keynote speaker by Takemi-san. So all papers are very interesting, and they did good research work. Probably Takiya-san also studied the influence of high-rise building and effect of the building height and impact assessment calculation. It is very interesting using WF model and a large area simulation models. It is very interesting. His research work is enhance a high concentration to this session. And also Afroza has presented climate scenario using trend of temperature and precipitation, and he found that temperature is increasing in a which is significantly statistically significant, and precipitation is decreasing but not statistically significant. And also Kormkar are also distributed using the observed data the maximum and minimum temperature over Bangladesh, and Shahana Islam is absent due to ill, and Professor Dr. Azam Chaudhuri has delivered his research work very nicely and found a strong correlation with climate factors with rising the sea level temperature. And also Jennifer Weeks and Professor Saiful Alam did a good job. They have find out with using different models of the sea level rise dynamics and projection, so that through this forum knowledge is shared with the participants. And I think this is not enough. We have to study. Professor Ishigawa-san already mentioned that study to understand the climate change and to adapt the future change impacts in our societal effects, so that we hopeful this will be done more fruitfully, and every participants and presenters and audience, especially thanks from my side. I am really happy and glad that good research workers from home and abroad did make the session very well, and interactive. And thank you, Isako Assam. Thank you very much to be here with you.
Thank you very much, Malik-san. You are really the good chairman. Chairpersons. I appreciate your summary. Okay, so let us close this session. Okay.
Thank
okay,
you,
thank
sir.
you, everybody. Bye bye, everybody, and we make a clap for all the presenters.
Thank you very much.
Thank you to both Dr. Terao sir and also Dr. Malik sir for conducting the session. And I thank all the participants for joining and having a very jovial participation, especially Dr. Takimi sir and also Dr. Karmakar sir, Dr. Ajam sir, and Ms. Afroza Sultana madam, and also a special thanks goes to both Dr. Jennifer and also Ben, and also Dr. Saiful sir. They have done a very good work, as mentioned by both the honorable session chair and co-chair. And I thank all the participants, and please know that we have another technical session 6, that is severe weather, which is roughly about 30 minutes from now. So see you there, and thank you.